Welcome to this technical walkthrough. Today, we are looking at a proof of concept that connects SAP Business Data Cloud data products directly to BigQuery and allow Gemini to use this data. In this video, you will see how we built an end-to-end Zero-ETL pipeline. We take standard SAP data products, share them with BQ, model the data there, and turn it into predictive insights using machine learning, and expose it to business teams through an autonomous data agent. Our goal is simple: to help risk managers identify customer operational friction and default risks early, using everyday natural language instead of complex SQL queries. Before we dive into the technology, let's talk about the problem we are solving. Today, enterprise financial data is locked inside complex ERP systems. When data is siloed, companies suffer from hidden risks, late payments, and slow reaction times. Extracting this data usually requires complicated IT projects, leaving business teams waiting days for simple reports. Our goal with this proof of concept is to change that. We expect to protect company revenue by turning static, backward-looking records into real-time, forward-looking risk predictions. First, risk and default analysts can proactively spot accounts that are highly likely to experience transactional blocks, helping prevent bad debt before it happens. Second, credit managers can instantly query open disputes versus payment promises using plain English, allowing them to focus their collection efforts on the accounts that need it most. And third, sales and account managers can use this system for secure cross-selling and upselling. By chatting with the agent, they can quickly identify which customers are financially healthy and low risk, making them perfect targets for new deals, while avoiding pitching to accounts that have active billing blocks. Let's look at how we built this. Let's look at the high-level architecture of this proof of concept. The whole system is built to minimize ETL effort and allow Gemini to access the data in a secure manner. It starts with SAP Business Data Cloud, where core enterprise data is packaged into clean data products. Instead of extracting this data through traditional middleware, we use SAP BDC Connect for BigQuery. This creates a Zero-ETL link, meaning BigQuery queries the live SAP data exactly where it lives. SAP BDC Data Cloud, after sharing, are visible as big lake tables. On top of these big lake tables, we build our BigQuery views. This is our semantic layer, which acts as a high-fidelity feature store, cleaning the data and preparing it for analysis. Next, our BigQuery ML model reads directly from these views to train a logistic regression classifier, scoring customer default risks automatically. Finally, we wrap everything in a BigQuery data agent. This agent acts as the natural language interface, allowing users to safely query the machine learning insights and the underlying views using everyday English. It is a direct, secure line from raw SAP data to intelligent business decisions. Next, let's navigate to the SAP DataSphere cockpit, where we can search for data products. While there are many standard data products available, for this POC, we need 3 specific ones: customer, promise to pay, and dispute case. Since these have already been added to my favorites, they are easy to locate. You'll also notice they are already shared with BigQuery. Clicking into a data product reveals its details, including the description, documentation, and data lineage. If we look at the lineage, we can see that this single customer data product actually contains multiple underlying tables. This means when you share the customer data product with BigQuery, you get access to all of these tables at once. As you can see here, this data product is already being shared with a couple of BigQuery instances. Switching over to BigQuery, we can see the data product shared with this specific instance as Big Lake tables. Under the customer data product, you'll see those multiple underlying tables we just discussed. The same applies to dispute cases, which contains several tables, while promise to pay includes just one. Now we can begin querying these tables. For example, if I run a query against the customer table, the data is pulled directly from SAP DataSphere, and the results are displayed right here. Now that our data products are in BigQuery, we can use BigQuery Studio to organize this SAP data into 3 key analytical views. First, Promise and Dispute Unified joins our promises and disputes into a single timeline. Technically, it handles the SQL joins, while for the business, it shows exactly what a customer owes versus what they are actively disputing. Next, Integrity versus Disputes analyzes whether broken payment promises are tied to unresolved billing disputes. This helps the business separate genuine cash flow problems from legitimate billing issues. Finally, high-friction customers consolidates all these credit metrics, risk flags, and external macroeconomic data. This serves as the ultimate risk profile for business users and acts as the perfect feature store for our machine learning models. Now, we train our predictive model. Instead of moving our data to external machine learning platforms, we do everything natively inside BigQuery using BigQuery ML. We build a binary logistic regression model called customer_risk_classifier. By running a simple SQL query, BigQuery trains the model directly on our final view, which combines customer details, promises to pay, and dispute cases. It analyzes historical customer behaviors to predict the probability of a customer triggering a central operational block or defaulting. Because this training happens entirely native to BigQuery, there's no need to export data. We maintain strict security, and the entire process finishes in just a few seconds. Once our model is trained, we deploy our live predictive view to put those insights to work. This is where we combine our historical customer data with real-time risk scoring. Technically, this view leverages the ML predict function, matching our trained classifier model against our high-friction customer view. By unnesting the prediction results, we extract the exact probability of a customer triggering a central operational block. For the business, this view brings everything together into a single line containing the customer's name, credit exposure, outstanding disputes, and a clearly calculated risk percentage. It effectively turns our static database into an active, forward-looking early warning system. Now, our predictive data is live and ready. For data analysts and technical users, accessing these insights is incredibly simple because everything is exposed as standard SQL. By running a basic select query on our customer risk predictions view, anyone can instantly pull the customer ID, country key, and their exact calculated risk probability in real time. There is no need to write complex code or export data to external dashboards. Any standard SQL tool or BI platform can query this view directly, putting advanced machine learning predictions right at your fingertips. While technical users can easily run SQL queries, business users don't need to write a single line of code. Instead, they can use BigQuery's built-in natural language chat with data option. By opening this chat interface and pointing it to our customer risk predictions view, anyone can interact with our data using simple, everyday English. For example, a credit manager can simply ask, "What is the total amount currently in dispute across all customers?" Or they can ask, "How many customers are predicted to have central operational blocks?" They can even go deeper and ask, "What are the key drivers or factors that contribute most to a customer being predicted to have central operational blocks?" Behind the scenes, BigQuery's built-in AI automatically translates these conversational questions into optimized SQL queries, runs them against our predictive view, and displays the answers instantly. It completely removes the technical barrier to accessing advanced machine learning insights. To make this conversational experience even more powerful, you can save your chat session as a permanent BigQuery agent. Once saved, this agent appears directly in the BigQuery agent catalog. From here, business users can jump in and ask questions anytime, without needing to set up the chat from scratch. Even better, you can generate a shareable link and open the agent directly in Data Studio. This gives your team a clean, dedicated interface to chat with your live SAP data and machine learning predictions, completely outside of the standard BigQuery developer console. It effectively turns advanced analytics into an easily shareable, everyday business tool. To wrap up, this proof of concept demonstrates how easily we can bridge the gap between heavy ERP transactional systems and modern generative AI. By connecting SAP DataSphere directly to Google Cloud, we have unlocked 3 major advantages for the business. First, we eliminated the need for complex, fragile middleware. By connecting natively to BigQuery, our data stays secure, up-to-date, and immediately accessible. Second, we kept our machine learning local and secure. Training our risk classifier directly inside BigQuery means we didn't have to export data or manage external analytical pipelines. And finally, we democratized these predictions using the BigQuery agent. Now any risk analyst, sales manager, or credit controller can get real-time default probabilities and outstanding dispute summaries simply by asking questions in plain English. This is the future of enterprise intelligence, transforming complex, siloed transactional records into direct, conversational actions that help you manage financial risk and protect revenue in real time.